Hi, in this video we will discuss about state pattern. State pattern is a type of behavioral pattern. Behavioral pattern is one of the category of design pattern. We discussed earlier in this course that we have three categories, that is creational pattern, structural pattern and behavioral pattern. So the state pattern is the one of the type of behavioral pattern. It allows an object to alter its behavior when its internal state changes. The object will appear to change its class. As we know that state of a variable or object change with the changing in the value of that object. When object changes value, its state changes. So it uses polymorphism to define different behaviors for different states of an object. Like we have a runtime decisions in our state pattern. It decides runtime that which class to be instantiated depending upon the value of that variable. So whatever the value that we have object is, the state is changing with respect to the object. So here is a simple dummy code that any person have some moods. Mood means states: happy, sad or sarcastic. So it depends upon the mood which things he reward to itself. For example, myself is equal to happy, it rewards its ice cream. So if myself is equal to sad, it go to pub. And similar to other states or events which we have, depending upon the mood or the state we have the person is. So state pattern is useful when there is an object that can be in one of several states with different behavior. So in each state, as we saw that this person has many states, so each states have some behavior. So it simplifies operations that have large conditional statements that depends upon the object state. So each state have some conditions while it invokes these methods or these triggers while the state is equals to that kind of value. So here is an example, is a UML diagram of our state pattern. State pattern here, water is a context where we are going to explain. It is more fascinated with the abstract class where we decide our states. We have three concrete classes that inherited or encapsulated with under the state of water. So we have a water vapor state, liquid water and ice state. So each these three states depending upon the event that occurs from the state of water. So increased temperature have some kind of conditions and have some kind of behavior. So while we decrease temperature, it invokes similar kind of method. So here is the client that invokes some kind of methods. It means events that occurs on the states of the objects. So when client invokes increased temperature, it's going to it checks the context of that the method that client invokes, and it sends this trigger towards the state of water. So increased temperature is directly invokes the subclasses that either can be from the water vapor, liquid water and ice. It depends upon the value that increased temperature method have. So it have three parts. When we have a context class, we have an abstract class, and we have three concrete classes. So the first thing that we must answer that how is state pattern is implemented. So one, we have a context class. As we saw, the water is the context of where we are describing the states. So the other states where we define different state of the state machine. As we saw in our dummy code that we have a happy state, we have a sad state, we have a sarcastic state. So in our this example number one, we have a vapor state, liquid state and ice state. So drive classes define the nature of that state machine can be in. So it defines the define the actual structure, actual context, actual behavior, actual conditions that method should be invoked from the context class. So context class maintain a pointer to the current state. it's save the current state through the pointer context. Pointer is just like our memory locator or memory locator we have. To change the state of that state machine, the pointer needs to be changed. So first we have some kind of state. The water is in maybe in ice state. After invoking the method of increased temperature, it may change its states to the ice to the liquid or liquid to the vapor state. So here is another very simple example that in the context of a person mood, whatever the mood he is have some states, have some mood states. So mood states only invoke through some actions which triggers. These triggers have some values. So according to that values, it invokes these three drive classes. So according to the action that a person perform, it triggers the mad state and the angry state and the happy state. So each these three drive classes have different behavior. So that's why we call that pattern is a behavioral pattern. And depending upon the condition of and the value of that method, it invokes the runtime behavior. I mean, it decides runtime that which state, either angry, happy, or mad, is to be invoked through that mood state. So the action is do something which is anything, which have any value that triggers either one of the three states. So this shows the polymorphic behavior, and this also shows the alteration in the value of object may alter the state of the person or the context class. So we have some benefits of using state pattern. First, state pattern localize all behavior associated with the particular state into one object. So as we saw in our last diagram, that is one object of the person mood, it alters behavior. So it localizes all behavior associated with a particular state into one state. So all these behavior, mad, angry, and happy, is stored in one of the mood we have in our diagram. So we discussed a new state and transition can be added easily by defining new subclass. So if we want to add some new moods, we just have to add some other drive classes that have associated some values that triggers on triggering the client method. So it simplifies the maintenance. If we want to add any behavior, any mood, so we do not need to change entire code. So it makes state transition explicit. I mean, it's the transition of the behavior decides on the runtime. Separate objects for separate states. Each state have a separate object that invoked on the state or condition and the value of that object. So it transition explicit rather than using internal data values. So define transition to one combined object. So here is an example that in this mood state we have combined object for these three classes that invokes depending upon the value that we have in the method from the client we have. So the next benefit we have in state pattern, the state objects can be shared. So the state objects can be shared through the context that can be shared objects if there are no instance variable. So similar in this example that we have a client that share all these moods and one of the mood or two of the moods that invoke through the value that it triggers through that invoke method, which is do something. So when we do code in Java or in any language, we have to define some values or conditions that if the client method equal to that condition, it invokes those kind of methods. So it can be shared, it can be explicit, mean it's polymorphic behavior, and it associated to one object. So here is a benefit of state pattern. So as we know in state diagram that states of the objects only alters behavior after when we have a change in our condition. So If you have any question, please ask in the comment section. We will answer those questions. If you like this video, please subscribe our channel. Keep watching. Thank you. Allah Hafiz.